Welcome back to the Foundation in C# course. We are currently in Module 7, and in this lesson, we're going to be covering another mini project. You'll see a lot of these mini projects throughout this course because I want to make sure we cover all the different project types that you go over. So we're going to have a mini course pretty much for every single one. Now, just like before, we're going to do the homework first, and then we'll come back and I will do the homework for you. So you can kind of do it yourself and then compare notes with what I do. Okay? So let's look at the homework. The homework is to build a WinForms application with 2 forms. Now, I only show you 1 form in the previous lesson. So you got to extrapolate and figure out how to do 2 forms. Create a form that takes in a person's information and another that takes in address information, multiple per person. So when you have the main form, let's say, with a person information, and where it says address, let's have a list box there. And when they click a button, it opens a new form. You can add an address in, and then they click the button again, or click the button on that new form, it saves it back to the list box on the first form. Okay? Maybe it sounds complicated, maybe it sounds like it's overwhelming, but just remember that all Windows forms are classes. You already know how to deal with classes and how to send information between classes. This is no different. So think that through and then tackle this homework. Okay? So I'm going to go ahead right now, pause the video, and go do the homework. At least give it a shot. Give it a shot, try it out, do what you can, and then if you really get stuck, come on back, but try and get it all done before you come back to this video. Okay? All right, I'm going to assume that you are done your homework now. If not, you missed your chance, but pause it now and you can do it right now. All right, so let's minimize this and get started on our new project. So our new project is going to be a Windows Forms app, .NET Framework. And let's call this WinForm Mini Project. And WinForm Mini Project app. That sounds good. And it's .NET Framework 4.8. And we'll hit Create. Now, with this project, because it's just user interface stuff, we're not going to add a class library. But just note that if we had any type of data access or business logic, those type of things, we'd add a class library almost right away so we have it and we're reminded to use it. Okay, so here's my pattern for creating a new form project. The first thing I do is I change that form 1 to be something else. I call it person entry. And it's going to ask me, do I want to rename things? What this is renaming is your classes. So this is the file. It's now renamed the code behind. Notice the code behind now says person entry. And don't forget there's also that partial class over here that is also called person entry now. So let's rename both of those as well. Okay, the next thing I do is I select the form and I shrink it down quite a ways. And here's the reason why. I'm going to change this form to have a different font size. And when it does, it's going to expand the form because of that font size. So let's first change the text the text from form 1, which is up here in the box. That's the one thing that doesn't get changed from form 1. Let's change this to person entry form by Tim Corey. And now that's what it says up in the bar here, and you can see, there you go. But next, let's scroll up on the form. If you don't have a form selected, if you have something else selected, you'll get this box right here. That's because the form itself is not selected yet. So you don't have all the properties you need. Make sure you single click on the form. If you double click, it's going to create that event that you have to get rid of. All right, so scroll up to the top here. Under font, there's that 8-point font that we need to change. Let's change that to 18-point font. And notice the form got bigger because of it. It's anticipating that the form needs to resize in order to handle the new font size. Since it's empty, it doesn't really, but that's how it does it. Next, have the same name except for that end piece because they go together. Now I'm going to highlight both of these by clicking and dragging, and I'm going to hold down my control key and drag down to make an exact copy of these. Since they are new instances of a label and a text box respectively though, they have different names. So last name label and last name text. And then for this one over here, when you come down here and change this to say last name. Okay, so now we have a first name and last name, and I think that's probably good enough. We don't have to go crazy with adding more and more things. You know what? Let's add one more thing that's a little bit different, and that is a checkbox. Just so you have a different control here. And the text is active. And that doesn't look left aligned, but let's make sure. Yeah, it is. Okay. So now we have first name, last name, and active, which is a checkbox. Just a different type. And that would be a Boolean, yes or no, true or false. So we'll have that new type, and then we're going to get a list box. Not a list view, a list box. And let's line this up. And we'll call this the addresses list. Addresses list is probably fine. We will call the actual list of addresses just addresses. Okay. And then let's grab a label for this. So control, whoops. I had two things selected. So I hit delete on that. There we go. Just the one. Drag it down. And now we can call this addresses for the text and addresses list label. Like so. And then we need to have a button here somewhere to add an address. I don't know where the best place to put that is. So for right now, I'm going to put it right here, right on top of the corner. I'll move it up a little bit. And we'll call this the add new address. And add, maybe add just might work versus add address. Something like that. That might work. Okay, so now we have our form pretty much created. The one thing I'm going to do is I've been debating. I think I really do want to have just kind of show off the class library, and so I'm going to create a button down here. And we're going to have this say save. Save record. And I didn't explicitly say to do this in your homework, but we're going to add this functionality. So I'm going to create a class library for this to save these objects. So right-click on solution, add a new project, and this is going to be a .NET Standard project. Oops, it doesn't filter by .NET Standard. So class library. Class library and .NET standard. It's unfortunate it doesn't filter by .NET standard. All right, we're going to call this, let's just go with demo library. We don't have a good purpose for this library other than to support our mini project, which is a demonstration, so demo library seems appropriate. Once we get this created, we'll delete class 1. And we'll right-click on the, oops, there we go. Then we can right-click on the project and go to class and create a person model. We get public. And we should also right-click and create a new class called address model. I'm going to do both at once because I really need to add a list of addresses to the person model. So let's do the address first. An address is going to be the street address. We could do street address too. We're not going to. Just street address, city, state, and zip. And this is a US-based address. Now, the one thing that may have thrown you a little bit is I'm storing my zip code, which, for example, a zip code might be something like 11852. That's a zip code. I'm storing that as a string. And so the question is, well, why are you storing that as a string? Well, one of the reasons is because this pattern is also a valid zip code. 00852. I'm not sure it's the actual zip code, but that pattern is where you have 2 zeros at the front. So how would that be stored as a number? Well, it'll be stored like this. That is different than this. Also, we have the idea of +4, which is where you have 4 digits after a dash. Now, you could store that as this, but here's the thing. Yes, it uses the numeric values, but it's not a number. And that's kind of a distinction to have there, is it's not being used as a number. You can't add to a zip code. You can't subtract from a zip code. It's not a quantity or something of that nature where by its nature it goes up and down or it can change based upon some type of math operation. A zip code cannot change because of math. So we store it as a string. Now, yes, you can get away with storing it as a number, and yes, databases do like numbers better, but it makes it more of a mess. And especially since you get into other countries, because again, this is a US-based address, but what if you decide to add Canada? Well, Canada has letters in their zip codes. Now you're up a creek. So this way, you're handling it either way. All right, so there's our address model, and it's been made public. So now you can come here, and we have our first name. And the new one is we have the is active. I have done in the past is alive. I think is active is a little nicer than is alive. Is active can mean more than just whether or not a person's alive, but is active can be are they currently using our service? And then we're going to have a list of address model called addresses. So there we go. There's our person model that links to a set of address models. And that's what we're creating on this form. Now you may be wondering, in person model, I stored it as a list of address model, not a binding list. And you say, well, but we're going to store addresses in here. We want a binding list so that we can see whenever anything changes. We want a binding list for our front end, but when it comes to storing data in our library, we don't want to have to concern ourselves with the user interface. And that's what a binding list kind of does, is it's letting people know, letting the user interface know whenever anything has changed. So that's a user interface specific type, at least how we're using it. And in the demo library should not care about user interface specific stuff. So therefore, it's being stored as a list. So we'll have to do some conversions there, and that's okay. All right, so back on our person entry form, I think we have everything listed here, and let's make sure that we don't have anything named incorrectly, and we don't. Our list all looks good. There's no ones at the end of anything. So now let's start wiring things up. So let's wire up first our address list, even though we have no addresses. So let's go to our code behind. And as I mentioned, that address list should be a binding list of type address model, which I don't have here yet. And if I control dot, notice it does say at the bottom, add reference to demo library. This is a really neat little shortcut. What this does is it doesn't just add a using statement for demo library, it also adds a reference to demo library in this project. So it basically right-clicks on references, goes to add reference, goes to the projects tab, clicks a checkbox next to the demo library, and then comes back over here and adds the using statement for demo library. All that with just a control dot and a, yep, I want to do that. So now that reference, notice the reference is right there in our references list. That reference has now been added to our project. We can go ahead and start using this. We'll say addresses equals new list of addresses. And I'm instantiating this here, meaning I'm creating a new instance of binding list because I'm not getting the value from a database. If the values are coming from a database, in my constructor probably, I would be asking the database for that list. And so I would not instantiate here. Down here in the constructor, once I get the list from the database, I would populate this addresses list with the values from the database. So I wouldn't have to do it twice. You don't want to instantiate something and then right away create a new instance of it and overwrite it. But in this case, I'm not calling the database. This is a brand new list, therefore I do instantiate it right away. Now the next thing we need to do is we need to put this list into our list box, our address list. So address list dot data source equals addresses. And you might think, hey, we're done now. Well, no, we're not. And here's why. Let me just show you. I'm going to write some demo code here that we're going to delete. So don't follow along necessarily. But if I were to say addresses.add new address model, and let's just say street address equals 123 State Street. The city is Scranton. And let's leave it like that. Okay? So we've added an address to our list before we added it to the data source. So it's already on the list. And if we run this, we should see one address, right? Well, let's run it and see what happens. We have demo library.address model. Why do we have this here? Remember I said that when we did the last demo where we had strings, we didn't have to specify anything because it did a toString on the value of string, which is just fine. That's the actual value. But a toString on a class instance is just the class name. So demo library.address model. And that's not what we want to see. So if you ever see this, it's because you haven't specified how to display your object. So we have to specify how to display our object. And that we do right down here, where we say address list dot display member equals name of address model dot, we can choose one of our properties. Let's just choose, for now, street address. And now if we run this, we get 123 State Street, because that's what we told it to display. So that's much better, but it's not ideal because of the fact that we're missing part of this address. Where is the city, state, or zip? Well, we're not showing every property, just one property. So how do we get around setting that up? Well, ideally what we'd do is we'd have a front-end model. And this is one of those things that people often get concerned about. The idea that you have a model that looks just like the model in your class library. But the front end might want to display things and have things for display in your model that the back end shouldn't need to know about. In this case, I'm going to not concern myself with it too much and say, you know what, I'm going to create something for display in my model itself. I'm going to create a read-only property that combines these values. So what I'm going to do is I could do a full property. Let me show you a full property, prop full. I can say string, and then I actually don't even have to have a private backing field. And I can call this the full address view or something like that. Remove the set, and then here I can return this value. I can create a string interpolation where it says street address, comma, city, then I can just paste in that one line. And that's it. Let's shrink this down over here so you can see the whole thing on the screen. So this line right here is the equivalent of this line right here. This is a property. It's a string property. It's a read only. Notice it says get only. And this lambda expression says, okay, here is the code I want you to return. In this case, it's just this line right here. That's it. Really simple stuff. If you had multiple lines, you have to put curly braces in a return statement, but we're not going to worry about that. We have just one line. So a lambda expression is a way of shortcutting things. So what it does, it says, I know I can assume certain things. So let's look at our full property down here with the read only. A lambda expression with just one lambda expression on a property says, well, if there's just one, I know it's a get. So you don't have to tell me it's a get. Let's get rid of that. And if you have just one line of things, well, I don't need to have all those curly braces because it's just one line. You have a semicolon at the end. Therefore, I understand that this is one line. I don't need a return statement because that's what I'm sending back, just that one line. Get rid of that. And I don't need those curly braces because it's just one line. So get rid of those curly braces. And that curly brace. And that curly brace. And now you have the equivalent of your lambda expression. So I just kept cutting things out that I already knew about. And that's how lambda expressions work. They're basically assumptions because we understand what's going on. And so that's how this works, and it makes it easier than trying to create a full property and cutting it down to what you need or typing it manually. State Street, Scranton, PA 18841. So that looks good to me. Now I can close this out. We also have a weird display issue. I clicked and dragged and forgot to click my control key, and I didn't copy. I just moved the last name. So let's do this again to give last. There we go. It wasn't capturing for some reason. And now this is first name label. Excellent. So this is last name label. And this is first name label. And let's change this to say last name. All right. So now that's a little better. The other thing I noticed was my tab stops. Tab over to hit save. So that should take care of our design. So now we have this ability to create a person in theory by clicking the add button. This is wired up. Now we just need to get some way of getting our values from a different form, which we haven't created yet, back to here. Let's start by creating our form, because once we have that, we have a better idea of how to work with it. So right-click on the Windows Form mini project and say Add. We could say New Item, or there's a shortcut down here for Windows Form. Let's do Windows Form, which just selects Windows Form in the list here. And we give it a name. And that form should have a name. It used to be we'd name our form starting with FRM. That's called Hungarian notation. And it's something that Microsoft encouraged about 2 decades ago. Now that's not something Microsoft encourages. Instead, we're going to use the Pascal case, and we're just going to call it what it is or what it does. So this is the address entry. What's the first thing to do with the form? Well, we've already renamed it, but now let's shrink it down, go to properties, let's pin these properties because we'll use them more and more. Go to our font, click the ellipsis, change this to be 18-point font, and then shrink it back down where we need it. With that being done, we can now create our address information. So I'll pin the toolbox back, and we'll drag a label on. Here's what you can do too. Let's do this. If you go to person entry and say, you know what, this looks a lot like street address and city and state and zip code really. going to copy these two things. So select them, Control C, come over here to your address entry and paste them. And we're all set. Now I could right align these. That might make more sense, where we bring it over closer to the boxes. I think that makes more sense visually. Like so. There we go. And the other thing I'm going to add is another label at the top here. And this is going to be our header label. And this, let's just call it address entry. And we're going to change the font size to be something larger. Let's do 28 sounds, or 26 sounds good. And bold. Yeah, it works. Something like that. That kind of we can center our form. There's also these buttons up here, which you can use for centering it and moving items if you decide that you want to have some type of design work. You can align these things together. So notice you can left align all of these items, which we've already done, but those type of things you can play with. And then we have a button, which we already have a button here at save. So let's copy this and let's just call it save. I don't see any reason to change that from what we have before. And save will also close the form. Now one thing I'm noticing is up here it says address entry. Let's change that to address entry form by Tim Corey. Yes, I'm branding it all over. You don't have to, it's up to you. Okay, so now we have our address entry form that when the user's on the person entry form, if they click the add button, we want the address form to pop up. When they fill out the information and hit save, we want the address entry form to close and to come back over here to the person entry form and add the entry to this list. That sounds complicated, but it's really not. Let's start with the add button. So double click on it to create the default event, which is a click event. So add new address underscore click. What's going to happen here? By the way, let's get rid of our sample code up here. We don't need that. So what's going to happen when the user clicks on the add address button? Let's talk it through. We want to open the address entry form. And that's pretty much it, right? Well, remember what the address entry form is. If you look at the code behind for the address entry form, it's a class. So how would you instantiate a class? Well, you do something like this, where you say address entry, let's call it entry, equals new address entry. That's it. We've now instantiated that new address entry form. Now there's one additional thing you have to do to actually make it show up anywhere, and that is say entry.show. So now, by just clicking on that button, we'll open up a new form. Let's start and just verify that's the case before we go any further. So we have our form, we click on add, and it popped up on the left over here, but there it is. So we hit save, nothing happens of course, but now we have at least the start of this form. Okay, now how do we get information from this form back to the original form? Well, here's what we're going to do. And this is going to use some advanced object-oriented thinking. And that's, again, why I really push the idea of learn the object-oriented basics and advanced stuff before you take on Windows Forms, because it just makes it easier to understand. We have this class instance here, and what we want to get out is a class instance. So what if we created, let's come up here and create an instance of address model. New address model. It's blank, it's empty, right? But what if we passed this address model instance into address entry? Then, if they modify this instance, however they modify it, what's going to happen is it's going to be modified on our side as well. That would work, and we can create a constructor that takes in an address model. But here is the downside of that. This new address, we could enter that in the list right now. But if we did that, then it'd be blank. There's nothing in it yet. And what if they hit cancel or close the address form out without filling it out? Well, now we have a blank entry in our list that we didn't want. So that's not entirely ideal yet. What we really need is a way for when they hit save, for this button to tell the person entry class, hey, I'm done. To do that, we could create a public method. So public void add new address complete, and pass in an address model that, let's just call it address, and the address entry could call this method. Yeah, kinda, but here's the problem. Then we have to know that you're a person entry calling. What if we want to do address entry somewhere else? Now we're tied to the person entry form. So here's what we're going to do. And I'm going to walk you through it, and then you can look back and see how this works. Okay, so I'm going to kind of go through the whole way, and then we're going to go back through and talk about it. So the first thing I'm going to do is go to my demo library, right-click, and add a new item. And this item will be an interface. I'm going to call it iSaveAddress. And yes, this is my demo library, not in my WinForms project, because while we'll use it in our user interface, it's not specific to one user interface. So this public interface iSaveAddress is going to have one public method called void save address. And it's going to take in an address model. Let's call it address. So that's the interface. Now, what does an interface allow us to do? Well, it allows us to say that whoever implements this will have this method. Entry form. Let's go to the code behind for that. I'm going to modify the constructor. The constructor is going to take in an iSaveAddress, control dot to add the using statement, an iSaveAddress interface. We're going to call it parent. And then I'm going to save up here outside of my constructor an iSaveAddress underscore parent. And that is who called me. Okay, so my constructor, I'm going to say underscore parent equals parent, just to save this parameter long term in my class. Now, when I have the save event, so let's go to our address entry and click save. Well, I'm going to create, at the very bottom, I'm going to say parent dot, I only have one method to call, save address, and pass in my address. They don't have yet, but I'm going to. So let's do that even right now. Address model, address equals new address model. I'm going to do my curly braces right away and say that the street address equals street address text dot text. The city equals city text dot text. The state equals state text dot text. And the zip code equals zip code text dot text. Put my semicolon at the end of that. And now I can pass that in to whoever called me, whether it is the person entry form or a totally different form. All I know is it's an iSaveAddress class. Not even a form, just an iSaveAddress class. The very last thing I'll do here is I will say this, for this instance, this dot close. And it closes the form. So I've called the save address, and finally I close out this form. So with all of that being done, now I can come back over here to my person entry. And notice how it says, hey, you can't do that. You need to pass in an iSaveAddress instance. Well, what is an iSaveAddress instance? Well, it happens to be this particular instance. The instance we're in right now is an iSaveAddress, and that's what you want. So you pass in this. So this just represents the specific instance we're currently in, which happens to be person entry, which is an iSaveAddress class. So that is all we have to do to wire up our save. Let's see it first in action, and then we will come back and look through these values. So if I say add, and let's say 1001 Oak Avenue, and that's in Scranton, PA 18847, and hit save. Check that out. It's now in our list in our first form because we're using object-oriented programming to pass values back and forth in a loosely coupled manner. So what are we doing here? In our new address click event, we are instantiating that address entry class, which that now requires our iSaveAddress. So we've given it that because that's what we implement on this form. This form has one public method, and it's save address. And so when we pass in that instance, we capture that instance and put it into a long-term variable, a variable that lasts for the length of the class instance, so that when we save this record, we can gather the information and create an address instance, and then send that to our parent via the save address method. We can close the form out, the form goes away, and now we're back over here where we've called the save address, we passed in the address, which we now add to our list. Now you may ask, well, why do we create that interface? Couldn't we just say person entry? So we change over here to say person entry, and nothing else changes besides those two values. This will work. So why didn't we just do that? Why do we create the extra step of an interface? Well, this address form right now will only work with the person entry form. If anything else tries to call it, then what will happen is it will say, hey, you're not a person entry form, or I need a person entry form instance and you don't have one. And that's messy. So instead, we use the interface so that if we decide later to create a is we want to show you how to create an object with things like the checkbox and this list box, which is a binding list. So let's do that. Double click on save, and we're going to do it work right here. We're going to create a new person model. And let's do our curly braces here. And let's start off with first name. That's easy. First name text dot text. Last name equals last name text dot text. Then we have the is active equals is active, which is our checkbox, is active, and we have a text, but that's a string, and that's not what we want. But if we scroll up here in our list, and these lists are awesome. IntelliSense is amazing because if you don't know what's going on, just scroll through the list and read the different things because it might give you some information. But we have, I believe it's is. Nope, it's not is, so it's probably just checked. Yep, checked. So this, the checked property, gets or sets a value indicating whether the checkbox is in the checked state. So it's either checked or it's not. It returns a Boolean. If it's checked, they're active. If it's not checked, they're not active, and will return the correct true or false value. So that takes care of our checkbox. And finally, we have the addresses. And addresses equals addresses, but that won't work because that's a binding list. So what do we do here? Dot to list. So it converts a binding list to a regular list of T. And now we've created our person object. We could do something with it. But I just want to show you we can create that person object. Let's put a breakpoint right afterwards. So we'll have this person object. If we hit start, I'll drag this over and I'll say Tim Corey is active, add somebody to the list, and test 1, 2, 3 PA like so. Yes, that's an ugly address, but that's okay. So is that. And yes, we have no validation on these boxes, and that's okay. We hit save, we hit our breakpoint, and notice our person object. Let's go to our locals here and look at the person object. We have first name of Tim, is active, is true, last name of Corey, and we have 2 addresses. The first address is the test address, and the second one is the really garbage address. Okay, so that now worked. Now we're not saving anywhere or doing anything with it, and that's okay. We're just running this to make sure that we understand how to do multi-form entry and list boxes and text boxes and even a checkbox, which you might not have done your own. That's okay. So with all of that, hopefully you've kind of grasped the concept of how to work with forms and different controls and how to use them. Remember, they're just class instances. And that kind of reminds me of our pro tip for today, which is forms are just classes. Form items are just class instances. So actually forms are just class instances as well. So with that, we can instantiate multiple of the same form if we want to, because each form is its own class. Therefore, we instantiate it, we create an instance of it. And every item on the form is just a class instance, so we can interact with it like any other class item. So for our form, when we had that form class, we actually applied an interface to it, because we control that class. We can add our own interfaces to it if we want, and we did. And so we were able to shape how that form works because we treat it like any other class. I know I'm kind of really focusing in on this, but if you grasp the concept of object-oriented programming and the fact that forms are just class instances, it really makes your life easier. It changes how you think about things. It's no longer just drag and drop. It's this is what I'm doing and why I'm doing it. Okay? So that's all for this lesson. If you didn't get it quite right, maybe go back and try upgrading your application or try again and see if you can't get some of the same results I did. And once you're done that, then let's move on to the next lesson.